Welcome back, everyone, in our machine learning sessions. So we were on the module where we were learning regression using scikit-learn library. So in this model, we are using Google Colab. And in Google Colab, we have followed certain steps, and the data this time which we have taken, that was car resale value. So in today's session, we are going to focus upon what are the inputs, means it is multivariate. What are the inputs which are going to impact the resale value of the car, and then we are going to regenerate the car value. So let's quickly see the steps which we have followed in in the previous session till now. So let's quickly move ahead. Step number one was we have imported all the libraries, which includes import pandas SVD, import seaborn as SNS, and we have imported matplotlib pyplot as PLT, which is going to help us to create charts. All right. Then we have taken sklearn, which is scikit-learn model of test train split, with which we are going to split the data, and the data is going to help us to provide the insights of what are going to be inputs and what are going to be the outputs. I'm going to show you the data also. Then we have seen how scikit-learn is going to evaluate the model using mean absolute error as well as mean squared error. Thereafter, we have imported NumPy as NP. Step number two was all about load the data set, with which we are going to find out what exactly is there in that data. Therefore, after reading the data, we have print first 5 rows of the data set. Step number 3 was visualize the relationships. There we have created multiple charts by using for loop. So for loop for car age, for mileage, for engine size, for horsepower, and for fuel efficiency. So one by one, when we are going to run this chart, it is going to provide us these insights like car age versus resale value. Thereafter, if you will be able to see that the new car, very less people are selling. Very new, only 1, 2, 3, 4. Thereafter, when the car age is approximately 12 or 14, the number is more, very frequent, right? Now, if we are going to say mileage, you can see a linearity in that, right? There is a linearity. This is car resale value in thousands, and this is the mileage. Here we have engine size and resale value. Very less impact in that because it is almost scattered, right? Now we have this horsepower, and it also shows some linearity in it, right? So if the resale value is less, like the horsepower is also less. If the resale value is 40,000, then the horsepower is also more. So it seems that there is some linearity. When the prices are higher, the you can say horsepower you are going to get, that is also good. Then we have fuel efficiency. Here we can see that very less correlation in it because it is also scattered. And thereafter we created a correlation chart by using correlation uh, heat map. Over here you can see that is our step number 4, which shows that correlation using heat map, and here we have used cool warm. If you are not going to give any of those, then it is going to create a red and the orange chart, which we created in the previous session, in the previous model, basically, where we have calculated, you can say, the house or the score of the student using TOEFL, GRE, and those on. Now we are going to, once we have seen the correlation, let me quickly take you through the correlation over here. Here is the resale value. So we are going to map, this is the most important row. When we are going to see the correlation of car age is 38%, mileage is 76%, car engine as it was scattered, as well as fuel efficiency was scattered. So very less correlation. Even if you are going to eliminate these columns, that is not going to make much difference in it. So this was it. Now quickly let's see over here, after we have created the correlation, we have we have prepared our data for test and train. We have created X as input and Y as output. With that, we have defined X as by dropping Y from it. Thereafter, we have prepared our data for test and train by creating the code line that is X train, X test, Y train, Y test. Then we have called upon the method from scikit-learn, that is test train split, where we have defined test size as 0.2, which is 20%. And we have kept random state as 32. You can take any random state, it's completely up to you. Thereafter, we have trained the model by using method of model.fit and calling upon the library that is called linear regression from scikit-learn. Once we have done that, now your model is absolutely ready. Even if you are going to ask your model by providing any test data to it, it will be able to share. And thereafter, we have calculated actual score over here. Over here, as you can see, MAE value. So basically, we are going to change it. One is going to be RMSE value. This is RMSE. And the above one is going to be your MEA value. We have run the evaluations. We have predicted the car value, resale value on the basis of the prediction. Thereafter, today we are going to create and we are going to make our model little verbose, which is going to help us to calculate the resale value of the car. Let's quickly get started with our next line of code. I hope till now you are at a stage where you have understood the entire model. I'm going to just reiterate once more how you are going to load the data. So what you are going to do, you are going to click onto it. And first of all, it is going to take some time to connect. Once it is connected, it is going to help you to load the data. As you can see over here. And here is the data you are going to connect. Once you have connected it, it will be helping you to show the result. Otherwise, it takes a lot of time. So as of now, you can see it is not getting loaded. So I'm going to try it once again. From here, I'm going to load the data. Okay, it shows a message. I'm going to do it once again, or just let me refresh it once again. So that let me see, because sometimes if your Jupyter notebook is not connected well, it shows this kind of error. Okay, so I'm going to load the data once again, connecting to a runtime. Yeah, now it is going to upload. All right. Yeah, now you can see the data is uploaded. Now we are going to write the next line of code. So here we have written RMSE is equals to NP dot SQRT, because we are going to now calculate the mean square root, that is mean squared error, and error of what? Y test and Y predict, right? This is what we will be doing. Yeah. So once we have done that, yeah, this line of code we have written already and we have printed also. So what I'm going to do, I'm just going to take this off. Yeah, predicted value we have done. Now the next part which we are going to do, we are going to put model evaluation, and this now we are ready to put our step number 10. Or basically 9. Step number 9 says you are going to run the comparison. So let's do the comparison. Comparison df and is equals to pd dot data frame. Here we are going to run for actual. It's single quotes. Actual. So you are going to run the prediction among actual data and y test values thereafter, that is going to be called as predicted. That is what we will be putting in because we needed to calculate the predicted value also. Once you are done with that, you are going to put y predict. Let me quickly explain this line with you so that you will understand. So here we are running our comparison, which is going to create two columns in front of you in which it is going to show you the actual data, which is over here. Actual data is what? Actual data is Y's test values and the predicted value. Predicted value is what? Your Y predict, which is being predicted by the machine model which you have created after model.fit. So once you have done that, now you are going to print it. Print, I'm going to put slash and this is backslash, okay? Actual versus predicted, yeah. And I'm going to close it. Yes. Now, once you have done that, now you are going to run print comparison df dot head. This is the function which I have created. It's print. All right. Now this is done. So once I have done that, it is going to actually show this, right? So let's quickly run this particular part and then I'm going to show you how you are going to create one more chart using SNS. So I'm going to run this. Yeah. Now over here, let's see what is the actual value and the predicted value. So over here, first five values. So I'm going to open uh, a sheet in front of you so that you can run your predictions and you can see. Let me open this data set and inside this data set only I'm going to keep the values. I'm going to open it. All right. So it is going to come in just one line. So what I'm going to do, I'm going to go to the view segment or data and I'm going to run this text to columns delimited next with space and next finish. Now you can see the actual versus predicted and thereafter there is actual versus predicted. So all have come in just one row. No issues. So we can see 0, 41 and 39. Then 26 and 24. So I'm going to just take this. There are different methods also with which you can do that. So it's completely up to you how you are going to use. It's just 2-3 lines. So that's why I'm doing it in a simple way. And the last one. Now you can see that there is very less difference in all of it, right? I'm going to delete these columns because these are not needed. So this is our actual value. Actual value was 41 and the predicted value which we have done that is 39. So I'm going to just calculate the difference minus this and therefore I'm going to run this for all the predicted value and then I'm going to calculate the sum of it. Okay. But this is an incorrect value as I have already shared and that's why we do mean square And by using numpy, we do the square root also at the end, because this is not exactly the difference. Here you can see 1, 1, 1. Here you can see -2, and here also you can see 1. So approximately 4 minus 2. So this is going to be the value along with the round off value which is there. So it is like not 3 actually, but if you are going to square off it and then you are going to convert it in positive, then only you are going to get the correct value of it. All right, which we have done with the maths which we have used using RSME. Over here in the code, if you can see, that's the same value which is given. All right, so this is your RMSE value. All right, let's quickly do that because we have not printed RMSE value. Print RMSE value. Print RSME. Yeah. Now if I'm going to run and show you, here you are going to get. Okay, let me see if I have written the correct spelling. RMSE. It's RMSE. This is the same value. MAE, MAE value, RSME. Yeah, now it is going to run. Let's see if we can find out. Yeah, now it is going to be there. Now you can see MAE value is 6.2, 1.62, and RMSE value is 1.88. So this is how you are going to calculate. Sometimes if it doesn't work, you can just, make the changes because bugs can come when you are working on online sheet because of the rendering or the connection. So you can just rewrite and run that again. It is going to work for you. So this is how this code is going to run. Now, once we have done that, let's quickly move ahead with the next code of ours. So here we have seen the comparison. Once you have seen the comparison, the next part which you are going to do, that is going to be how you are going to predict the value. So let's quickly predict that value. So what we are going to do, SNS dot SEA TTER plot. And here we are going to put X is equals to Y test and Y, this is small y is equals to Y predict. Right? So this is what we have done. PLT dot X label. And here we are going to show you actual resale value. So there I was not able to calculate because we were working on Excel, but here we are going to do so PLT dot Y label. So here what I have done, first of all, I have created X and Y as labels. With the help of those X and Y labels, it is going to create the graph for us. All right. Predicted resale value. All right. Now the next line of code is PLT dot title. We are going to give it a title. All right. Let me just, yeah. PLT dot TITLE. PLT dot title. We are going to put actual versus predicted resale values and done. Then PLT dot grid, and we are going to make grid as true. Yeah, true, and PLT dot show. That's our favorite. Show. Yeah. Now, once we have done that, we are going to see how it is going to form. All the graphs are done here. Now, can you see actual versus the predicted value? So here is the predicted value and here is the actual resale value. And you can see that there is linearity, not much difference. And this is the scattered graph which is going to show. So in fact, there also, if the predicted value is of the resale value is going high, thereafter, the actual value is also going high. Now, what we are going to do after creating this chart, I'm going to get started with next step number 10. Now we are going to predict the new data price. So that is what we will be doing. And for that, new input. So if someone is putting in a new input, how you are going to calculate it? So we are going to put np dot array, and we are going to create, I'm going to put the values, that is going to be 3. Then I'm going to put after 3, the second value is going to be 3 or 30,000. Then 2.0, then 150, then 18. And I guess this much value is fine. These are all inputs which I am giving in. Now engine size. So these are what? These are engine size, horsepower, fuel efficiency. Now what we are going to do, we are going to call upon the model. Predicted value. Predicted value is equals to model dot predict. And what we are going to predict? New input. Right? This is what we will be predicting. Now we are going to enter print. We will be putting in the predicted value of a new resale value. So we are going to print, and in the formatted string also you can put predicted value 0, and 0 is going to be multiplied by 1,000,000, that to 2f. All right, so this is what we are going to put, and then we are going to close the string. Okay, so we will be starting from here. So this is going to be a formatted string, and I'm going to close the string here, right? So likewise, you are going to put, I'm going to, because this is your, yeah, 2f close. Now it's done over here. Yep. I think now it's completed and I'm going to run it. So this is the entire code. Now let's quickly run and let's quickly see. Okay, actual value. And now you can see with these data, the predicted value of my resale of the car is 40,641. So this is how you can also, change the input and you can get. Now I'm going to change the input. First of all, we are going to do the car age. So I'm going to change car age to 5. And the second value which you are going to change, that is going to be your engine size. So basically, or the kilometers or the mileage, that is going to be 50,000. This is going to be 1. This is going to be 80. Instead of 18, I'm going to keep 20. And now let's see how it is going to predict this value. If my car is 5 years old, now you can see 37,315. So every time you are going to change the input, it is going to provide you a verbose. It is going to provide you a new, car price in rupees, in thousands. So this is how we have created this model. I hope you have enjoyed it. Now let me quickly recap. Here we have finished our regression with scikit-learn using scikit-learn. In this, we have created two models. One is code prediction and the second one is car resale price prediction. With these two models, we have understood how linear regression works with only one variable or one input, as well as with multivariant multiple inputs. With that, thank you everyone. I hope you have understood it and keep practicing, keep learning.